So for section 10.4, we're going to be looking at the different types of polynomial symmetry and how we can test for them without having to graph them. In other words, how we can test to see if certain polynomials have symmetry without actually putting them on a graph and drawing them. So the three different types of symmetry that we're going to look for is y-axis symmetry, x-axis symmetry, and origin symmetry. So let's look at this. Y-axis symmetry basically means if you graph it, there will be symmetry along the y-axis. In other words, the left side will be equal to the right side, flipping over the y-axis. Now, for that to happen, your points have to be xy. They also have to have the points negative xy. In other words, for y-axis symmetry, your x's need to be opposites, and I'll show you how to do that in a minute. X-axis symmetry, let's go number 2. X-axis symmetry basically means you have symmetry along the x-axis. So now you've got symmetry along the horizontal axis. For x-axis symmetry, your y's have to be opposite. Once again, I'll show you how to do that in just a second. And last but not least, we're going to look at symmetry around the origin. Now, symmetry around the origin is the y equals x line, and it's symmetrical across that line. For symmetry to be about the origin, you have to have opposite x's and opposite y's. Now remember, the goal is to be able to determine what types of symmetry we have without actually graphing the line or the curve. We want to be able to tell just by looking at the function, and this is going to be the key. So I'll show you that in just a second. So let's go ahead and look at the function 4y squared equals 2x. Now remember, to test for y-axis symmetry, you actually want to make sure you have a negative x. You switch your x's. So what I'm going to do is I'm going to go into the function. Remember, we don't want to graph it. I'm going to go into the function, and I'm actually going to take that positive x in the function, and I'm going to change it to a negative x. And then I'm going to kind of clean this up and simplify it as much as I can. So that would actually be negative 2x. What you want to do is compare the original function out here to this new function once it's simplified as far as it can. This says equals 2x, this says equals negative 2x. They are not equal, and since they are not equal, I do not have y-axis symmetry. Now I'm going to test for x-axis symmetry, and remember, to test for x-axis symmetry, we change the y's. Okay, so I'm going to go into my problem, and instead of squaring a positive y, I'm going to square a negative y. Well, we all know that negative times negative actually will convert that back to a positive. If I look and compare the original to this new simplified, they are identical, meaning that we do have x-axis symmetry. And then for the origin, what we're going to do is we're going to change both. So we're going to change the y to a negative, and then we're going to change that x to a negative, and we're going to simplify it as far as we can. Negative y becomes positive y, and that becomes a negative 2x. Okay, once again, this is not the same as the original because of that negative 2x, and therefore we do not have symmetry about the origin. The only symmetry we have in this particular case is x-axis symmetry. All right, let's take a look at another function. If you remember correctly, for y-axis, we change our x. So I'm going to take this original function, I'm going to make it from a positive x to a negative x. There is no simplifying to do here. And you can see it obviously does not equal the original function, therefore there is no y-axis symmetry. For x-axis, remember, we change our y's. I'm going to go in here, change my y. Now, we all know the absolute value of a number is always a positive number. So that negative will actually clean itself out once we take the absolute value, making the original and this one the same, meaning we do, in this case, have x-axis symmetry. And for symmetry about the origin, we're going to change both. That y is going to clean itself out, but that x is not, meaning it's not going to be the same, and we are not going to have symmetry about the origin, meaning once again we have x-axis symmetry alone.